architecture talk, so we'll just get that sorted, and he'll be on in a second.
All right. Okay, so hey everyone. Eric, talk to me, Gooseman. I was the Barry bench warmer. Once we figured out Barry couldn't come in and do a talk, I had to cobble together something. So we'll see how this goes. Yeah, apparently I added too many slides, but we'll see how things go. Building extensions, architecture lessons learned sometimes the hard way. So I have a number of extensions that I built on the App Store. So the GitHub Project extension, Better Information Panel, Stream Teams extension, Stream CC, and then just a small hashtag Go Vote just to make people aware about going to vote. I'm going to talk about 4 of these extensions, not the hashtag Go Vote. That one's easier. So the things I'm going to go over today are architecture, the architecture of the extensions, some mistakes I've made during my development process, and also some of the improvements that can be made or I have made to my existing extensions. So I hope that I know some of these moments are going to be kind of cringe, and some of you guys are going to be like, "Why did you make that decisions?" But the thing is like when you're working on stuff, it's just it's just a process of creation. It's use whatever technologies what you're comfortable with, and just enjoy it and just build stuff, and build things that you want. And sometimes you'd be surprised who else wants to use that extension too. So just to cover what extensions are just essentially just simple little web pages that are trapped on the. Yeah. So yeah, they're just little web pages trapped in iframes on the Twitch channel. So people they're not something sophisticated. I'm getting requests to add this on the TwitchDev documentation page that we should add this as a. The very first extension I ever made was the GitHub Project extension. This was back when it was first publicly released to us developers. I asked myself, what do I want? And I was like, you know what? I want to show off my GitHub projects, so why don't I just build an extension? And that's what I did. So I built a panel extension. It displays your public repos. It integrates with the GitHub API, uses React.js, and it's powered by Firebase Cloud Functions and Firestore. So you're going to see a lot of this. No AWS, unfortunately. A brief overview of the architecture. So as a streamer, you come in and you go to the dashboard, and it does some requests to the Cloud Functions, and it queries the Firestore, the database, and sees if you're set up already. If you're not, it'll ask you to put in your GitHub information, and then it will communicate with the GitHub API, where then it'll fetch your information and you can do the setup. On the viewer side, what happens is that it'll do another request to the Cloud Function, and it will just fetch everything out of the store and then present that to the user. So fairly straightforward. So it's fairly straightforward interface architecture, but how can you improve on this using existing Twitch APIs? Enter in the extension configuration segment. So when you go to the documentation and you read this, let's read it verbatim. So it's sets a single configuration segment. Any segment type is specified by a required body parameter. Each segment is limited to 5 kilobytes and can be set at most 20 times per minute. Updates to this data are not delivered to the extensions that have been already rendered. So in layman's terms, this is a data store. This is storage for you to use on Twitch that Twitch has provided you. You don't have to pay anything to use this. This is a database. And in certain respects, we can treat it like a NoSQL database. So you can just throw strings up there and then format it whatever you want. So equipped with this knowledge, what could we do with the GitHub Project extension? Boom, get rid of Firestore, exactly. So we got rid of Firestore, and now we can use the configuration segment. Unfortunately, we still have to kind of use the cloud functions because because the GitHub API is authenticated, so we can't just directly throw data in there. We needed to use a secret key for that information. So now that we have our data stored in the configuration segment, how is the viewer side going to look? Boom. Now, when the channel page loads and it fetches information, I'm like totally distracted by the thing. It just does queries directly to the configuration segment. So no longer do we need the cloud function or the Firestore. Now we can just query directly to Twitch API and get data out. So what are the improvements for the GitHub project extension? So using this knowledge that we've equipped it, we can actually eliminate the Firestore completely in favor of the extension configuration segment, and then potentially eliminate requests to our function. And the bonus is we save money, or I save money. Yeah, I still need to do this, by the way. All right, so the second extension I built is the Better Information panel. So it's a panel and video component. It supports tabs, so it's basically like the panels below the stream, but it's like on steroids where it supports tabs. You can do like, it has like markdown preview and like changing colors and tab titles and stuff like that. It's built with React, uses Firebase, Cloud Functions, and Firestore. The API architecture for this is really straightforward. It just, if you streamer, it goes to the dashboard, and then goes to the Cloud Function, stores that information in Firestore, and then on the viewer side, it does the same thing. It does a request to a function, fetches from the Firestore. Now we talked about the configuration segment. The improvements that we can make on that is, boom, we can completely actually eliminate the need for APIs or the Firestore, because when they're setting things up, we can directly just store that information into the segment. So now the improvement to that is, the benefit is that we just completely eliminated the need for a backend. We completely eliminated the need for a database. And actually, this extension ends up just costing me no money because we're not doing any authenticated requests to third-party APIs. We're just storing data into a store that Twitch is providing us. So the lesson learned from this is that you might be able to eliminate your database and even some of your function calls by just using the configuration segment that exists that Twitch is offering. So if you are planning to build an extension or already have one, you should try checking this out and to optimize your APIs or save some money. On to the next extension, and this one's going to be a little more interesting. So the stream extension that I built is a panel extension, and the objective is to display either your Twitch team, if you're part of a Twitch team, or if you're an affiliate like myself at the time, you're not part of a team because you're not privileged enough, so you can build your own team. This was built using React, and again, Firebase Cloud Functions and the Firestore. So the architecture to this was a little, similar to the GitHub Projects API, where the streamer sets up some information about either the Twitch team that they're on, or automatically fetch the Twitch team that they're on, or they can configure their own custom team with title and users, and that would communicate with the Twitch API and then store that into Firestore. So I'm making a very clear distinction of the mistake I started to make. I stored all the information about the teams and the users into my database. I thought I was getting clever, by caching all this information. I had not too many requests to the Twitch API, so I started doing that. So then on the viewer side, when it starts fetching information, it goes, when they load the page, it goes to the function, queries the Firestore. Sometimes it'll query the Twitch API because there's a feature I'll go over in a second about clearing cache and refreshing data, and it fetch all that information and store that into the Firestore again. So that wasn't a good idea. So I wanted to break it down exactly what happens, and this, I thought this would be kind of enlightening. So the client is a user that's visiting the channels page. They do a request. It hits the EBS, in this case, our cloud function. It does a query to the Firestore, and then it double checks, hey, do I need to refresh my cache? Because Twitch teams user information changes. You can change your handle, you can change the contents of your team. You can just get rid of someone, add someone to the team. refreshes that information, stores it on, and then sends that back to the user. And then I thought like a really cool feature would be like, you know what? Why doesn't my panel just show who's live on the team? Is that really cool? You know, you can scroll down and see who's live. So like, you know, I implemented this kind of like polling mechanism on the UI where it requests to the function about getting a live list. You know, requesting the people that are live, queries Firestore, double checks the refreshing the cache, which I think the cache was also 5-minute timer, and checks who's live, stores all that information, and then sends that request back. So this section right here ended up being a problem for me. So one thing you have to know about using databases as a service, not like Postgres or anything like that, is that they bill by the size of the storage and data coming in and out. You know, I'm doing polling every 5 minutes, you know, during a query. Firestore contains a lot of information about the users, a lot of information about the teams. And, you know, I'm doing this for every single channel viewer. So, you know, like there's thousands of viewers, you know, in a channel. Needless to say that once I implemented this, costs skyrocketed. And so I immediately turned this off. So whenever a polling request came through, I just returned back a 200 saying, hey, yeah, it worked. So yeah, so I came back and I'm like, okay, we need to work on a 2.0. So instead, enlightened with some information about how better to use the data, what I ended up doing is, again, the client ends up doing a request to this function where we query from the Firestore, but this time I optimize it so I'm just storing simple IDs. Whatever team that they're on, I store their ID. And if they're doing a custom team, I need to remember who the user IDs are for those. I just send those back, and then I let the client do the request. So instead, I request from the client on the UI, I do a request to Twitch API and fetch all that information before loading and displaying it to you. And then for the live feature, I was able to enable that because now that the UI knows who the team is, who the people on the team are, I can just do simple requests to the Twitch API and do request. And this, you're not going to get rate limited because this is the rate limit. It's based off each client. So it doesn't, even though your client ID, even though it's doing requests all over your client ID, it's spread across all these users that are using your extension. So you don't have to worry about that. That's originally the mistake I made with assumptions on the Twitch API. So my costs went down. It went down from dollars a day to 1 cent a day, maybe, depending on peaks. That makes sense. I got it. So yeah, so mistakes and improvements that I made to this team extension. So I stored way too much data. You can delegate some of that work to the client, especially if you're working with the Twitch API and you're dealing with APIs that don't require secret keys. Why don't you just have the client do the request for that information for you? Another improvement is I saved a load of money. Before I turned off the live polling thing, I was trending at $20 and keep on going, and now this costs me cents on the dollar, from the dollar, whatever. And then the bonus thing about this was that I ended up solving the stale data problem because, as everyone knows, you know, when you're trying to cache data on the database, you'll come across stale data. But now that the client is in charge of fetching that information, I no longer have to deal with the stale data problem that some people were emailing me about, like, hey, you know, why am I on the Twitch team? So that actually ended up being a bonus to solving this with this new implementation of the workflow. So yeah. Pay attention to your cost at scale, regardless, in regards to your data usage, and because things that make it crazy. Because you know, it's like, yeah, you're using the cloud function. You're using like Azure functions, AWS function, like Lambda functions, whatever. But pay attention to the other services you're using. I didn't do that, and I paid the price for that, literally. So the last extension, and I flipped this because the slides didn't fit very well with all the text. So this is why it's kind of like off center and stuff like that. So this is like my baby. But based off all the lessons learned, this is the extension that I built for not this current Dev Jam, but the last Dev Jam. I was inspired by NoopCat herself about building a closed captioning extension. So yeah, so this extension is a video overlay and panel extension that actually offers closed captioning on your stream. It adds an overlay on, and you can do closed captioning. It's built with React.js. It uses AWS Elastic Beanstalk, PostgreSDB, Redis cache, and then uses a speech-to-text JavaScript API that Chrome offers for free. So the users are restricted to using Chrome for this because they offer it for free. And then I enabled. Recently released translations using Azure's bit-enabled translations, and uses the configuration service configuration settings that we talked about before for user settings, and then also uses the PubSub API that Twitch offers for broadcasting to all the channels for multi-tenant support. So the overall architecture is this. So on the bottom left is the broadcaster. They're on the website, on the companion website, enabling go on Chrome, turning on speech-to-text. From there, it sends a message. It takes all the text that's happening on the browser side, sending that information over to the server through Elastic Beanstalk, where it handles the load balancing to EC2. And then I do some Redis caching, some storing on the Postgres database if you want to do transcripts, and like there's user data because like you have to actually log in, so I'm authenticating requests. And then from there, I am publishing that information to Twitch itself. So I'm publishing the messages to Twitch using their PubSub API, and any new settings that they do. I recently released, in honor of International Pirate Day, I released Pirate Talk mode. So like it converts all your English to pirate lingo. So when you say what, it says shiver me timbers. Yeah, so it publishes all that information, and then on the client side, when viewers are watching the stream, they get that information coming from Twitch, not from my servers. So yeah, so I thought this is kind of a cool diagram to kind of show like the overall architecture of it. So the broadcaster turns on the closed captioning at the top. The dashboard UI connects to your mic, starts listening to whatever microphone you're using for your streaming, and then every second it sends the speech-to-text information to my server. It does it every second because the PubSub API is limited to one publish a second. So one thing to note if you want to use this API. It does some logic here in the boxes about enabling bit translations. So it listens to transactions. It determines whether it needs to deduct from your bit balance. And then if you are doing translations, it will then do a request to Azure, where the service I'm using to do translations. And I'm able to do this in line because Azure actually returns back in like 10 milliseconds the text that it's being translated. And right now it supports 4 languages. So that's pretty amazing. And then from there, I publish out the payload to Twitch, and then Twitch is responsible for getting that payload to all the users on various streams. And then the only thing that actually hits my server is when the client actually wants to triggers bits, does a bit purchase. The client actually does a request to my server to say like, hey, like someone just purchased translations, and do all the lingo to enable it. So yeah, so this is kind of like my baby, and like I took out all the mistakes I made. So there's not many things that I can think about improving on it right now. One thing that I can potentially use is Twitch released a WebSocket for transactions. So instead of sending post requests to my server to get notifications about transactions, I can instead listen to a WebSocket and then process that potentially. And one other thing that I didn't think about that I actually just found out the other day looking at the TwitchDev Discord was that maybe I could actually use the local storage on the browser potentially to store the closed captioning messages that are coming in to do some more creative things. And because right now all I'm doing is just concatenate into one giant string, which is I felt like was inefficient. So maybe I can put all those strings all those published new strings that are coming in into the local storage and using that instead. So that's one potential improvement I can make. So I just want to say, take a look at the documentations, regardless of what you guys think about it, think of them. There are great APIs for them. Sometimes they're hard to read, but there are things for you to use on there to make. There are really great things there. Like the dev teams made a lot of great APIs and things for you to use to make your extension great. You just got to you just got to go on the Discord or just ask for help, if you're not sure. So yeah, that's it.
Thank you very much. And last of all, we've got Bryce or Bressy, an admin from the forums again and from the Discord, and he's doing his talk on why your extension won't work. So I'll hand it over to him.
We will need the mouse, so will it work? No, I will need the mouse to start my video.
I